Hello everyone. Good evening. Welcome to BYJU'S exam prep. Just let me know once whether the voice is clear or not. Good evening. Welcome to BYJU'S exam prep. Just let me know once whether the voice is clear or not. Yes. So according to me, the voice is absolutely fine. So we can start our session, I guess. So guys, this is me, Saket Verma, and we are now going to start the special 26th session, and here the subject is EMFT. So just comment in the comment section that how many of you are already live in the session and have shared the session with all the other friends. Yes, Kumar, and yes, absolutely fine, is saying. So guys, before starting the session, I would like to introduce myself. So this is Saket Verma and I have done MTech from IIT Guwahati and I have carried a different PSU exam as well. So here you can see that I have area of expertise as the electromagnetic theory, communication system, advanced communication, signals and system, etc. And similarly, I have the Telegram group and the link is also given. This is the link of the Telegram group where you get the daily dose and also important questions and the link of the sessions. So all the upcoming sessions link will be shared in this Telegram group. And there is a very good announcement for all the BYJU'S families or the BYJU'S students and those who are going to prepare for the ESC that we have achieved a very good rank in the UPSC ESC 2023. So you can be part of our your ESC or officer becoming officer journey and if you can join our session also. So guys, this is the first question according to the wave propagation. So as I told you that here we are going to discuss the questions related to the wave propagation, related to the normal incidence. And if you have any query related to these topics, then you can ask me. And I will also discuss some of the theoretical part of the wave propagation, some of the theoretical part of the normal incidence. It would be around 1 hour session. And in this 1 hour, we will discuss about the two topics. So special 26 is all about the important 26 topics that are going to help you for your preparation of GATE 2024. Okay. Good evening, Akhil. So guys, quickly solve this session and give me 1 second. I'm just 1 second. I'm coming. So electrical field phasor of uniform plane wave is given and E is equal to A by 10 into e to the power j 0.2 z. If the phase velocity of the wave is 1.5 into 10 to the power 8 into 10 meter per second. Hello Banu, good evening. Yes, Bharat, if you are not satisfying the eligibility criteria, then whether you are the first ranker of any other exam or in the ISRO exam itself, or whether you perform the excellent in the interview, you will not be able to get the document verification and you will not be able to get selected because there are multiple aspirants, those who have eligible and those who are also having the a good rank in the exam and good score in the theoretical exam. They also satisfy the minimum criteria, minimum performance in the interview. So they have to shortlist you if you are not able to fulfill the eligibility criteria, है ना. अगर आपका eligibility criteria fulfill नहीं है तो definitely आपको वो लोग document verification में reject कर देंगे irrespective of कि आप कितना theory में marks ला रहे हो. ठीक है. कितना भी आप थ्योरी में मार्क्स ले आओ, उनके लिए ये मैटर नहीं करता, दैट इज जस्ट एलिजिबिलिटी क्राइटेरिया फॉर देम. So, according to the standard expression, we know that this is nothing but a vector E is equal to E naught and E to the power J, because it is written in this form, so it is G beta Z and A E cap. So from this equation, if you compare your given expression, if you compare these two expression, then आपको क्या मिल जाएगा, इलेक्ट्रिक फील्ड का पीक वैल्यू विच इज 10 वोल्ट पर मीटर मिल जाएगा, और बीटा की वैल्यू मिल जाएगी 0.2 रेडियन पर मीटर, और इलेक्ट्रिक फील्ड का डायरेक्शन मिल जाएगा, दैट इज योर ए वाई. एंड अगर हम बात करें तो हमको डायरेक्शन ऑफ इलेक्ट्रिक फील्ड मिल चुका है. ये तीन चीजें मिल जाएगी, और आप ये भी बोल सकते हो कि अल्फा की वैल्यू यहाँ पे 0 मिल जाएगी. ठीक है, तो ये चार चीजें आपको समझ में आ गई. अब आपको वेवलेंथ अगर कैलकुलेट करना है, तो वेवलेंथ का जो पहला हमारा जो क्वेश्चन है वेवलेंथ, तो वेवलेंथ का फॉर्मूला क्या हो जाएगा, 2 पाई बाई बीटा. ठीक है, तो वेव प्रोपोगेशन किसी भी पर्टिकुलर मीडियम में आपको डेफिनेटली पूछा जा सकता है, तो ये एक इंपॉर्टेंट टॉपिक है वेव प्रोपोगेशन का. सो 2 पाई बाई बीटा, और यहाँ से आप लिख लो 2 पाई अपॉन 0.2, और ये आ जाएगा आपका 10 पाई. सो दिस इज योर वैल्यू ऑफ लैम्डा, 10 पाई 31.4. बिल्कुल ठीक है. ठीक है, तो ये आपका एक पार्ट हो गया. सेकेंड पार्ट है आपको फ्रीक्वेंसी निकालना है. ठीक है, फ्रीक्वेंसी निकालने में कोई दिक्कत नहीं आएगी, क्योंकि फ्रीक्वेंसी होता है आपका वेलोसिटी, एंड लैम्डा इज इक्वल टू सी बाई एफ होता है ना. लैम्डा इज इक्वल टू सी बाई एफ होता है, तो एफ इज इक्वल टू वीपी अपॉन लैम्डा. लैम्डा हमारे पास है वीपी हमारा 1.5 इंटू 10 टू द पावर 8 आ चुका है, एंड द लैम्डा इज 10 पाई. ठीक है, तो इसको अगर हम लोग सॉल्व करेंगे तो हमारे पास फ्रीक्वेंसी क्या आएगी, हाँ भारत, फिर कोई दिक्कत नहीं है, फिर कोई दिक्कत नहीं है, वो उतना कंसिडर हो जाएगा आपका. देखो, who does not know theory, let me just know whether you have in the final year or the pre-final year. Okay, 4.7 megahertz आ रहे हैं. How many of you are getting 4.7 megahertz? सेशन का ड्यूरेशन आपका 1 आवर का रहेगा. सेशन का ड्यूरेशन हम लोग 1 आवर से ज़्यादा नहीं रखेंगे. नहीं, इशू नहीं आएगा आपको, बिल्कुल उतना राउंड ऑफ किए हो आप, तो अगर आप सेटिस्फाई कर रहे हो बाकी सारी चीज़ों को, तो आप वहाँ पे बोल सकते हो कि कितना राउंड ऑफ किए हो. बोल रहे थे आप 10th परसेंटेज राउंड ऑफ कर दिए हो ना, तो 10th में कितना परसेंट, क्या परसेंट था और कितना राउंड ऑफ किए हो. ठीक है, if it is not given then we will take it as a non-magnetic medium. Okay, relative permeability is given, so it is 2.4 given. So if it is given then we could not take. Zero point 2 pi frequency, you have got 4.77 into 10 to the power 6, and 3 into ओके. हाँ चलेगा, चलेगा, चलेगा भारत. उतना 64.5 है, 65. अच्छा, 65 एलिजिबिलिटी क्राइटेरिया इसरो का तो 65 होता है ना. एलिजिबिलिटी क्राइटेरिया 65 होता है कि नहीं, तो फिर आप तो 64.5 आपका एक्चुअल है ना, तो आप कैसे बोले कि सेटिस्फाई हो रहा है एलिजिबिलिटी क्राइटेरिया. if you are 64.5 and the eligibility criteria is 65, then you are not eligible. अच्छा ये तो हमारा 10th का बोल रहे हो, ठीक है, ये 10th का है। हाँ 10th का चलेगा, 10th का चलेगा, कोई दिक्कत नहीं है, 10th का कोई दिक्कत नहीं है। ठीक है ठीक है। ठीक है भारत, चलेगा फिर वो। So according to this is coming as 1.67, हाँ 1.67 आ जाएगा आपके पास। हाउ मेनी ऑफ यू गेटिंग, यस यस, नो दिक्कत भारत, कोई दिक्कत नहीं आएगी, श्योर हूँ मैं। 1.67 आ जाएगा। और एक्सप्रेशन ऑफ मैग्नेटिक फील्ड लिखना है आपको। सो मैग्नेटिक फील्ड का एक्सप्रेशन आ जाएगा, वेक्टर एच इज इक्वल टू पीक वैल्यू एच नॉट ई टू द पावर जे बीटा जेड और डायरेक्शन ऑफ मैग्नेटिक फील्ड। सो एच नॉट को आप लिख सकते हो ई नॉट डिवाइडेड बाय एच नॉट इज इक्वल टू ईटा होता है, तो आप लिख सकते हो ई नॉट डिवाइडेड बाय ईटा एंड ई टू द पावर जे बीटा जेड एंड डायरेक्शन। ठीक है, डायरेक्शन हमको ये दो चीजें निकालनी है। एंड बीटा निकाल चुके, जेड का ये तो ठीक है। ईटा, ईटा की वैल्यू हमको निकालनी पड़ेगी, तो ईटा इज इक्वल टू 120 पाई रूट ओवर म्यू इंटू एप्सिलॉन आर, है ना। तो म्यू आ रहा है 2.4 और एप्सिलॉन आर हमारा 1.67 आया, ये आ जाएगा। तो ये कितना आ रहा है, 120 पाई 452, है ना, 452 मान लेते हैं रफली। 9.4 2.94 आ रहा है, सो 10/452 एंड ई टू द पावर जे, बीटा कितना था 0.2 जेड, so 0.2 z direction of magnetic field, so direction of magnetic field is AE cross H, so AK cross AE आ जाएगा आपके पास। डायरेक्शन ऑफ प्रोपोगेशन नेगेटिव z है, और डायरेक्शन ऑफ इलेक्ट्रिक फील्ड, डायरेक्शन ऑफ इलेक्ट्रिक फील्ड पॉजिटिव y है। सो ये AX आ गया। सो 22.12 मिली एम्पियर आ रहा है, तो 22.12 e to the power j 0.2 z and AX milliampere per meter. So check how many of you are getting the same answer. How many of you are getting the same answer? Okay, ठीक. So you have got this. Now solve this one. Next question. How to contact whom? If you want to contact ISRO, then just check their number in the notification or email them. In magnetic field expression, eta should be present, sir, because E lacks H. Eta is present na, already. Eta I have mentioned. Na? We have calculated eta. What is the value? 0.1339. Attenuation, you are getting 0.1339. Okay. See, if I calculate it as it is given, the eta value of eta is given here. The value of eta is given. So now if you want to calculate the attenuation constant, then we have to use one relation, that is the alpha divided by beta is equal to tan theta eta. And because it is the root 10 theta eta is 30. So this is nothing but the alpha is equal to beta into tan 30. So what is the value of beta? The value of beta is 1 by 2. So it is, and tan theta is also 1 by root 3. So 1 upon 2 root 3 you are getting, correct? 1 divided by 2 root 3. So it is coming as 0.2886 Napier per meter. That is the value of alpha. Now we have the skin depth. So this is the for the calculation of first part. The second part is skin depth. Skin depth is delta is equal to 1 by alpha, which is 2 root 3, because alpha is 1 upon 2 root 3. So it is 2 root 3. So we are getting 3.464 meter. So 3.464 is the skin depth. And now we have to calculate the electric field and the direction of polarization. So to calculate the electric field, we know that this is how we calculate the electric field. Eta is having the expression as E naught and e to the power minus alpha. The direction of propagation is x, and then cos of omega t minus beta, which is 1 by 2x, that is not going to change, and the direction of electric field. So there are two things that we need to calculate, which is eta naught. So eta naught is eta into h naught. So eta is 200 at an angle of 30 degree multiplied with h naught. H naught is 10. So we are getting 2000 at an angle of 30 degree volt per meter. And the direction of electric field, the direction of electric field is direction of magnetic field cross product with direction of propagation. So what is the direction of propagation? The direction of propagation is x. So what is the magnetic field? Y. So y cross x. So it is coming as minus z. So what is the expression now? E is equal to E naught. E naught is 2000 at an angle of 30 degree. E to the power minus alpha. Alpha is 1 upon 2 root 3 x, and cos of omega t minus x by 2. The direction is minus az. So if you write it, so this is 2 e to the power minus x upon 2 root 3 cos of omega t minus x by 2 plus pi by 6, and this is minus az. So how many of you are getting the same answer? Just let me know. How many of you are getting the same answer? The value of beta I have calculated from the given expression only. The given expression is this, and which you compare it with the standard one. E naught e to the power minus alpha x cos of omega t minus beta into x a h cap. That is the standard expression. So if you compare, you will get the value of beta. Okay. So what is the direction of polarization then, Meghna? What is the direction of polarization? Yeah, the direction of polarization is in the direction of electric field. The direction of polarization is equal to direction of electric field. So direction of electric field, what is the direction of electric field? That is the negative. Minus minus that direction. Okay, the Ashish is said minus z. You have to mention the direction, na? Negative also. The negative is in the negative z direction. So you have to tell the negative z. Okay, now try this. So Ashish has got the answer. Otherwise, others also can tell. Yes. So for a uniform plane wave of frequency 10 to the power 6 hertz propagating in a good conductor, Okay, so propagating in a good conductor, the field undergoes a change in phase by 2 pi radian. So change in phase. So there is a phase change with respect to distance. So what is the phase shift? Okay, the phase constant denotes the phase shift per unit distance, right? So phase shift per unit distance is given by the beta, that is the phase constant. So phase shift is how much? 2 pi. How much is the distance? 1 meter. So what is phase constant? Beta. And it is a good conductor. So for good conductor, skin depth is equal to 1 upon alpha, and alpha is also equal to 1 upon beta. So here we will get 1 upon 2 pi meter. So the right answer is option A. Correct. So all of you have given the right answer. Now try answering this one. Okay, so try answering this one. Yes, all those who have given the option A has got the right answer for the previous question. Now answer this one. In the last line only, we have to calculate the electric field. As you can see from the option, the electric field you have to calculate. Okay, the permittivity and the electric field. The permittivity and the electric field. Options are here. The option D I am writing. Epsilon R is 9, and this peak value is 120 pi. And here it is option B. Epsilon R is 3, and 360 pi is the peak value. So if you are not able to see the option B and D, then this is option B and this is option D. So Ravi Teja is giving their answer. Now other also can solve. For those who are having any doubt, peak value of electric field and the permittivity you have to calculate in this question. Okay, so here you can see that the when we compare with the standard expression, the beta you can get, which is 280 pi. Okay, with the help of beta, you generally calculate the permittivity. Remember this, that whenever you want to calculate the permittivity in the wave propagation chapter, you have to use the beta. That will give you definitely the permittivity from the any question you can just pick up and you can solve. You will definitely get the permittivity with the help of the value of beta. And generally the questions have framed in that way only, or otherwise the second parameter that by which you can calculate the permittivity is value of intrinsic impedance. So in any medium, if the beta is given, then you can calculate. If you, the permittivity is given, then also sorry, impedance is given, then also you can calculate the value of mu r or epsilon r, whatever it is asking for. So here it is simply saying that it is a non magnetic medium, so relative permittivity is 1. So the beta is 280 pi, which is omega by c root over mu r into epsilon r. So 280 pi into 3 into 10 to the power 8, and the frequency is 2 pi f. F is how much? The frequency is 14 gigahertz. So 14 into 10 to the power 9. So if you will check this pi and pi will get cancelled. 14 into 2, 8, 28, 28 and 28 will get cancelled. And here we have the root over epsilon r. Okay, so this 10 to the power 8 and this will cancel. So how much you are getting? 3 only you are getting. So epsilon r is equal to 9. So epsilon r equal to 9. So either option C or D will be correct. Epsilon r will be 9. Now after this, you need to calculate the peak value. So this peak value is equal to the peak value into eta. Okay, so peak value we want to calculate for electric field. So here we have the 3 and the 120 pi, and eta is how much? Eta is 120 pi divided by root over epsilon r. Root over epsilon r was 3. So this is 3. So 3 and 3 will get cancelled. We will get 120 pi. So yes, option D will be the right answer. Option D, Ashish, Meghna, Chinmay, Ravi Teja. Yes, all of you are right. Guys, the Poynting theorem, how many of you knows the Poynting theorem? The Poynting theorem is integration over the closed surface. Okay, integration over the closed surface, the E cross H, that is power time average Poynting vector, or the power, total power flowing through the volume. Let me write in this way. Integration over the closed surface, E cross H, that is power through the closed surface, is equal to integration over the volume sigma into E dV. Okay, then minus of del upon del T, and 1 by 2 mu H square dV, or minus del upon del T, integration over the volume. And if I have taken the volume integral, then I should write in this, not in this way. Undo, erase it. I am writing in the volume now. So let me write in this way, dV and integration over the volume minus 1 by 2 epsilon E square. Okay, dV. So that is the Poynting theorem. Okay, the Poynting theorem says that this is ohmic power dissipation. Ohmic power dissipation. And this is rate in decrease, decreased in rate of energy stored in electric field and magnetic field. Okay, for these two, you can write in this way. Okay, so this is your time average Poynting vector. Now also you know that the time average Poynting vector is, when you want to calculate the power, then you can use this. This is the Poynting theorem. This is the second thing that you can use. Time average Poynting vector. The third thing you can write is the time average Poynting vector is also given as 1 by 2 real part of electric field and magnetic field complex conjugate, right? Or also you can write E naught square upon 2 eta cos theta eta and e to the power minus 2 alpha z, and direction of propagation. For lossless medium, the alpha will be 0, theta eta will be 0, so you will get E naught square upon 2 eta sigma E square. Yes, this is sigma E square. There is a sigma E square. Yes. Because we get the JC plus JD. Okay, JC plus JD. This derives from the JC plus JD, and this is your curl of H. Okay, so we take the dot product of E both the side. So when you take the dot product of E both the sides, so here you will get 1 by 2 epsilon E square, and from this you will get the sigma into E, that is the conduction current density, and then this E, because of the second E we get sigma E square. Yes, Vikram. That's correct. Sigma E square. So I wanted to check that how many of you actually knows the Poynting vector, means this equation, because that's why I intentionally wrote the wrong one, that anyone of you whether gives the raise the question or not. If you are not raising, that means you are not just right now you are not able to recall that maybe. So that's why I just intentionally wrote the incorrect equation so that you may raise the question that sir whether it should be there or not, like Vikram did. Now try answering this question. Now try answering the question. Okay, the incoming solar radiation at a place of on the surface of the earth is, yes, here that something is missing. Just give me 1 second. I will check and confirm you. Ashish has got the answer D without the correct question. How? You know this? It is 1.2 kilovolt per meter RMS. Now tell me the answer of this question. Kilowatt per meter square. You have to calculate the RMS value. Okay. Let me write in this form. The incoming solar radiation at a place, the electric field value, RMS value you want to calculate. Okay. If I ask you to calculate the RMS, then what will be the answer if the question is asking for the amplitude of electric field corresponding to this incident power is nearly equal to, that is the RMS electric field corresponding to. I am changing this question little bit. Tell me what answer you are getting. The RMS electric field corresponding to this incident power. What will be the answer then? If it is the question. What will be the answer according to this? Option D is still. See, incident power, it is asking electric field corresponding to this incident power. So according to this, option D, all of you are saying option D is still. I am asking the RMS value, but see, the time average Poynting vector is E naught square upon 2 eta when the E naught is the peak value. Okay, when the E naught is the peak value of electric field. But I am asking about the RMS value. So the RMS value is obviously calculated as E naught divided by root 2. So when you square it, you will get E into RMS square divided by eta. So E RMS is equal to root over eta into time average Poynting vector. So eta is 377 and time average Poynting vector is 1.2 into 10 raised to power 3. So I would like to know that which answer you are getting approximately. So it is 377 into 1.2 into 1000. So it is coming as 672. Okay. So the RMS value is coming as 672.6. Okay. I have changed the answer a little bit because obviously that is none of these will be the option for this according to the change question. If it is not a RMS value, then the right answer is 950. But I asked you to calculate the RMS value. So the right answer would be 672 volt per meter. Yes, 672. Vishwajit, there may be some technical issue, so it will come live again. Don't worry. Now answer this question. Because of the technicality, there might be some uh, it has got private. Otherwise, it will come. Don't worry. Want to answer this question? So as you guys, you can see that here we have a non-magnetic medium. What is the intrinsic impedance and the time average power carried we are asking for, and also determine that time average power crossing through this. So first of all, the time average Poynting vector it is asking. So the time average Poynting vector is nothing but the E naught square divided by 2 eta and the direction of propagation. So E naught is 4 whole square divided by 2 into eta, but here the eta is not given, so we will calculate that. So first of all, we need to calculate the epsilon r, which is nothing but the beta into c upon omega. Okay, so beta is 0.8, c is 3 into 10 to the power 8, and omega is 2 pi into 10 to the power 7. So it will get cancelled. We will get 12 by pi. Okay, so root over epsilon r is 12 by pi. So 120 pi into root over epsilon r. So we will divide it by 12 by pi. So here we will get the 10 pi square. So 16 upon 2 into 10 pi square. So we can say that this is nothing but the direction of propagation is also there. So 81 milliwatt per meter square. Okay, 81 milliwatt per meter square. Impedance 98.74 you are getting, but I have calculated directly. Okay, so just check once that the time average Poynting vector you are getting this or not, and according to the direction of propagation it is AX cap. The direction of propagation is AX. Now you want to calculate the power integration, and here we have the time average Poynting vector dot the differential surface. So that is time average Poynting vector integration over the surface 81 into 10 to the power minus 3. Direction of propagation is x, and when you calculate the normal direction of this, then it is 2ax plus ay divided by root 5. Correct? So integration over the surface. Now and dx dy also will come. Okay, that is the ds. ds is this one only. So when you calculate it, the magnitude is 100 into 10 to the power minus 4. So it will come as 81 into 10 raised to power minus 7 into 2 upon root 5. Time average Poynting vector getting the same answer. Okay, getting the same answer. Now what about this 81 into 2 divided by root 5? Are you getting the 7.24 microwatt? Are you getting 7.24 microwatt? Yes. Okay, perfect. Now try answering this one. This is a question from the normal incidence. What is electric field? Yes, you have to calculate the electric field at 10 centimeter. You have to calculate the electric field at 10 centimeter. Here it is written now. The electric field at the point after 10 centimeter. After 10 centimeter, you have to calculate the electric field. Okay. After 10 centimeter, you have to calculate it. In the dielectric, inside the dielectric, after 10 centimeter, what will be the electric field? That is the question. See how to solve this problem. In this question, this is the first medium which is there and has the impedance 120 pi, but the dielectric is having the permittivity and permeability, which is a complex quantity. And first of all, you have to calculate that what is the value of electric field exactly at the boundary. Once you get the electric field at the boundary here, then after 10 centimeter you can calculate, because as the wave travels in the medium, the wave can attenuate if the medium is lossy. So first of all, you have to also find whether this dielectric is lossy or lossless, because if it is lossless, then whatever electric field you get in the boundary, that will be same inside the dielectric because there is no loss. But if there is a loss, then whatever electric field you get at the boundary, as it travels down the inside the dielectric, that will get attenuate. Okay. Yes, we have to assume the sigma 0, because in this question the sigma is not given. And whenever the electric field is the permeability and the permittivity is given as a constant complex number, then you have to apply the general equation. So what is the general equation for calculating any parameter like gamma, like eta? So we have the j omega mu divided by sigma plus j omega epsilon. This is the general equation. So as I told you that in such type of questions, if the sigma is not given, then you have to assume 0, because there is no other way to solve this problem. So j omega will get cancelled, and we will get mu naught, which is 1 minus 2j mu r, and epsilon naught, which is also 1 minus 2j. So this will get cancelled and we will get 120 pi, because this will 2 get cancelled. Now to calculate the value of alpha, whether it attenuates or not, we will calculate the alpha. So this is j omega mu and sigma plus j omega epsilon. So again the sigma is 0. So we will get j omega outside, and here we will get mu naught into mu r and epsilon naught into epsilon r. So we can say that this alpha plus j beta is j into omega by c 1 plus 2j, because this is nothing but the c mu naught into root epsilon naught root over it is nothing but 1 upon c, and mu r is 1 minus 2j, and mu r and epsilon r both are same, so it will be outside. So now if you compare it, you will get the value of alpha. You will get the value of alpha as it is minus there. So 1 minus 2j. So what is the value of alpha? The real part. So 2 omega by c will become the value of alpha. What is the frequency? The frequency is given as 1.1 gigahertz. So 2 pi into f divided by 3 into 10 to the power 8. From here you will get alpha. Now, first of all, whatever wave is coming from the inside, from the first medium, that is air, how much part is reflecting, that also you have to calculate. So this is the reflected electric field divided by incident electric field is nothing but eta 2 minus eta 1 divided by eta 2 plus eta 1, which will be, this is the value of eta 2 because it is calculating in the second medium. So both are same. So 120 pi minus 120 pi divided by 120 pi plus 120 pi. So it is coming as 0. So that means there is no reflection. So ER is equal to 0. That means there is no reflection. So incident wave is equal to the transmitted wave. That means the 10 volt per meter. So alpha you are getting 2.303, you are saying? No, I don't think so. Yes, just let me calculate first. I will explain what is actually your doubt. It is 2 into pi into f 1.1 into 10 raised to power 9 into 2 divided by c. It is 46.07. Yeah, so what is your doubt, Meghna? What is your doubt? Exactly what is your doubt? I said that if the medium is not defined and also if the medium is not defined and also the permittivity and permeability is given complex, then you have to use the general equation. So that is your eta 2 and this is your gamma 2, that is alpha 2, beta 2, all you will get. And from here you will get the attenuation constant in the medium. So as wave travels, it will get attenuated because of this alpha, because the alpha is non-zero. Now, how much part of the incident wave is reflected? But because the eta is same in the both mediums, so air and the dielectric both are having the same dielectric, so there is no reflection from the incident wave. So if there is no reflection, then the 10 volt is coming from the air, so it will go means at the boundary there will be same magnitude, so the electric field at the boundary will also be 10. Now as the wave travels down in the waveguide in the medium, dielectric medium, then it is E is equal to E naught, that is the transmitted wave, e to the power minus alpha 2 and whatever direction it is. So it is asking for the 10 centimeter, so it is 10 into e to the power 46.07 in 10 centimeter means 10 into 10 to the power minus 2. So now you can. Vikram, we will discuss it tomorrow because I have the time limit and right now I have to finish the session after this question and then we will take that question, your doubt question, tomorrow in the beginning itself. Okay, in the beginning itself I will take that question, red light question. Na? So it is coming as 0.1. 0.1 volt per meter will come. Okay, 0.1 volt per meter will be the right answer. If you have any doubt, just let me know. 0.1 volt per meter will be the answer. Meghna, is it clear now? Okay. Okay, guys. So we will meet in the next session tomorrow at the 7 p.m. Okay, tomorrow at 7 p.m. we will meet because today I have to go somewhere. So that's why I kept the class at 6 p.m. But tomorrow at 7 p.m. I will take the class. And in the beginning, the Vikram has asked some questions. So I will take that question first and then we will start our transmission line questions. Okay, and you can download the BYJU'S exam prep app because you are going to get the many free sessions and also the leaderboard. And we have a grade 2025 and 2026 course we have launched, so you can contact in this given number and you can inquire about what are the things you are going to get here. You are going to get some live classes, recorded lecture, etc. So you can ask everything what is in your mind before taking any particular course from anywhere. You can just talk to them what you are going to get, what is the fees, etc. Okay, and thank you for watching this session. Don't forget to download BYJU'S Exam Prep app and stay tuned with us, and don't forget to subscribe this channel. Thank you.